So as I said, we're going to start kind of this whole conversation about psychology as it pertains to the entire rest of the semester by looking at the science behind how we study the brain and human nature and how we develop in our memory, right? If we don't understand the basic ways to read a graph and to understand the statistical relevance behind some of these studies, none of this is going to even be worthwhile. So here we have this idea of what is the scientific attitude, right? A lot of this might be review from some of your science classes or other classes that you've taken that have a scientific kind of foundation, but we do have to recognize that within psychology there is a need for critical thinking. This critical thinking refers to a more careful style of forming and evaluating knowledge than simply using intuition, and so from that we understand you can't just go with your gut to understand why people behave the way that they do, right? Instead, we need to, by extension, apply what we have come to know as the scientific method, so that critical thinking can help us develop more effective and accurate ways to figure out what makes people do, think, and feel the things that they do, right? So with that, your textbook kind of outlines a couple of different aspects to this idea of critical thinking and what it takes to have this scientific attitude. One is curiosity. Somebody who's curious is always asking new questions and trying to figure out certain things about the world, right? You have to have a sense of humility on top of that curiosity, right? You're asking questions, but on top of that, you're seeking the truth rather than trying to be right? Doing scientific studies and implementing research isn't about proving your hypothesis true. We're actually going to look at some of these ideas in terms of like confirmation bias and errors in thinking in the future. But for now, we just have to understand that humility is really important in this practice, right? It's not about being right. You need to be able to be wrong and accept that you're wrong in order to better understand what's going on. The last kind of aspect that the textbook outlines in terms of what you need to have a scientific attitude is this idea of skepticism, or not accepting a fact as true without challenging it, seeing if facts can withstand attempts to disprove them, right? This idea that seeing isn't always believing, right? What you see isn't always what you get. And so we're going to watch another video here. This is a study that was done at an art museum in which they took twins. They had one chewing gum and one not chewing gum, and they asked people from the streets to kind of rank which one they thought is nicer or more attractive or would give you a speeding ticket or whatever, all these questions. And they kind of rank them based on this idea of one is chewing gum and one is not. So the hypothesis here, right, if we're thinking about the scientific method, right, the hypothesis is that chewing gum creates a positive impression. While you're watching this, think about, is this in fact accurate? Can you be skeptical about the outcomes of what this research is showing us, right? So think about that idea of skepticism and the scientific attitude as we watch this research, and we'll talk about it here in just a sec.
Welcome. Which one seems like he has more friends? Which one has more imaginary friends? Which one gets invited to more parties? Which one gets invited to more bridge tournaments? Which one is the bad cop? Which of these bosses would give you a raise? Which one would fire you when you ask for a raise? Which one has a better sex life? Which one never puts money into the employee gift pool? Which one really enjoys giving you a ticket? Thank you.
So after watching that video, right, we know a few things. Overwhelmingly, people associated more positive actions with the person who was chewing gum. Even though these twins look the same, they're identical, right? The company, they controlled for things like their clothing and their hair, their makeup if they were wearing it, their body language, right? They controlled for a lot of this stuff. The only thing they changed was whether they were chewing gum or not. And it's easy to say, well, yeah, that makes sense, right? Chewing gum does make somebody have a positive impression of them. But we have to remember that there are potential conflicts of interest. There are aspects of the research process that aren't being depicted. There are potential confounding variables, right? We'll talk about some of these key kind of buzzwords in just a second. But like looking at this particular study, and we're talking about potential confounding variables. Hopefully, right, we're talking about being skeptic. We're talking about using skepticism and questioning everything, right? Potentially, when we're talking confounding variables, the act of chewing gum creates a more relaxed facial expression, which is compared to the twin who's not making any facial expression at all, right? So it's not so much the act of chewing gum, but it's the actual facial expression that chewing gum presents to people, right? We also didn't see the sample selection. We don't know who was coming into this art museum to rank these people. We don't know what happened following the experiment, right? And then lastly, and kind of in terms of conflict of interest, the big one, right? This was funded by a gum advertising ploy, right? And so they wanted you to say they wanted you to come to the conclusion that chewing gum makes you more likable or looks like you have friends or whatever the questions were. So just kind of think about that. When we're talking about a scientific attitude, looking at research, understanding where that research is coming from so that we can make true and factual conclusions based on what we are observing. So this is just one example of that. We're going to continue on here looking at different aspects of the scientific attitude in just a sec. So looking at this slide, this is just kind of taking that idea of critical thinking to the next step and actually putting into words kind of what that example research experiment we just watched is trying to get at. The slide itself didn't really transfer into this recording platform very well, so I'll just read to you the definition of critical thinking, which seems to be cut off here at the bottom. But critical thinking is analyzing information to decide if it makes sense rather than simply accepting it, right? The goal is getting at the truth, even if it means putting aside your own ideas. And so the way in which we engage in this critical thinking, right, in this skepticism, this curiosity and humility, bringing all that together within the scientific attitude, right, we have to see if there's a flaw in the information, in how the information was collected, right? Looking at that research experiment, who were the people doing the ranking? right? Who came into that art gallery and clicked the button, right? Consider if there are possible other explanations for the facts or results, right? We talked about a relaxed jawline and relaxed facial expression has more positive connotations with it, and therefore that's why people more closely associated positive feelings with somebody chewing gum, right? That could be another possible explanation, right? The next one, looking for hidden assumptions and decide if you agree, right? Thinking about where are these assumptions coming from? Is it because it's an advertisement funded by a gum business or gum company? Looking for hidden bias, politics, values, or personal connections. Again, that confounding variable, that conflict of interest, and then putting aside your own assumptions and biases to look at the evidence itself. So just kind of think about some of those things as they pertain to our understanding of having a scientific attitude. As we continue moving forward, we're going to look at some of the failures in our thinking styles, and then go on to the actual scientific method, break that down just a little bit further. So here we have some of those natural thinking style fails. The first is hindsight bias, right? That's going to be this idea of I knew it all along, right? You're working through an activity, an assignment, a problem in life, whatever, and it's really difficult, it takes you a really long time, and then all of a sudden you figure out the solution, and you're like, oh, well, yeah, I knew that all along, right? Even though it was really difficult for you. We tend to do this, our brain makes some of those assumptions or associations kind of to protect our own self-esteem. We also see the coincidence error, or mistakenly perceiving order in random events, right? This example, which is cut off on this slide, the dice must be fixed because you rolled 3 6s in a row. Well, rolling a dice is a random act. Even if, how many times have you been like, oh, I rolled a 6 3 times. There's no way I can roll a 6 again, right? There's the same exact chance that you're going to roll a 6 again as any other number, right? So we make those mistakes in perceiving order in random events. And we also have what we call an overconfidence error, right? I am sure I am correct, right? I only know what I know, and therefore I'm using what I know to form my opinions and my ideas, and therefore what I know is right. Right? We have this overconfidence error that is a part of human nature. So what I want you to do when we're talking about overconfidence, I want you to just look at this slide. I'm going to have you pause the video here and go ahead and answer questions 1 through 5. If we were in class in person, we do a lot of handouts that are similar to this. But for now, pause the video, go through and answer these to the best of your ability. I'm going to give you the answer in just a second, and we'll see how confident you really are and put this overconfidence idea to the test. Here are the correct answers, right? So looking at the idea of how big the area of the United States is, it's 3.6 million square miles, okay? So you're looking, I feel 98% certain that the area of the United States is more than blank square miles, but less than blank square miles. If you if your range contained 3.6 million square miles, there you have it. Number 2, looking at the 2008 population of Australia, 21 million people. Are you right or are you wrong? Did your range include 21 million people? Number 3, looking at the number of American battle deaths in the Spanish-American War, all you people who are taking or have taken U.S. history, let's see what you remember. Not that we taught you specific death numbers. The answer is 385 deaths. Number 4, in 2005, the number of female psychiatrists in the United States was 13,079. 13079. That number is actually lower than I probably would have assumed. Number 5, then, looking at nuclear plants in the world, there are 439 nuclear plants in the world. So again, looking at your range that you put down, how confident are you? And when we look at these numbers and look at kind of where you were right and where you were wrong, it's easy to recognize this overconfidence bias. What in the world is this? Okay, it looks like some of the circles from our next slide came on here, whatever. Overconfidence is obvious. If students are as correct as they are confident, only 2% of your responses should be wrong, right? Thus, if each of the 50 students responds to 5 questions, there should be a total of 5 errors, right? That's pretty unlikely that across the board, all of you guys only got 5 errors. The actual proportion of errors will be much more than 10 times that. And so we know that overconfidence is in fact a real psychological occurrence. We're going to study it further later on in the course. But this is just something interesting to think about when we're talking about that scientific attitude and how we approach our understanding of these research studies. So from an evolutionary perspective then, why do we make these errors and overuse our intuition, right? Like we know based on scientific attitude, we can't just go with our gut, but like sometimes that's the best option. And if we're looking at an evolutionary perspective to these thinking mistakes, right? Hindsight bias might be an offshoot of our useful habit of analyzing an event and trying to figure out why it occurred, right? We look at this happened, why did this happen? I understand why this happened. And therefore, hindsight bias can be kind of over-applied to our own understandings and interpretations of events, right? Perceiving order helps us make predictions, and then overconfidence might just help us lead other people, right? Certainty builds confidence in followers more than accuracy does. And that can just kind of be, again, this is an evolutionary perspective. We started the lecture with a talk about perspectives and applying examples to those giggling teenagers with cute teachers. Again, this is kind of another take on those perspectives. So today we're going to transition and look specifically at the scientific method. And we know that the scientific method is a process of testing our ideas about the world by setting up situations that test our ideas, by making careful organized observations, and by analyzing whether the data fits with our ideas. The data doesn't fit with our ideas, then we modify our ideas and test again. So this hopefully will be a bit of a review. We're going to kind of frame the scientific method through the lens of psychology, but I do know that you've gotten some of this content in other science courses, so we'll kind of get through it a little bit quicker than maybe we would if we were learning it just for the first time. So the basics of the scientific method: you have a theory, you have a hypothesis, you have operational definitions, and you have replication. These are the key kind of definition terms that you need to know. We also know that there are different types of research that have different goals. You can describe, you can correlate, make a prediction, prove causation, or conduct experiments. So we're going to break these all down just a little bit more and kind of think about how, again, this scientific method relates specifically to the discipline of psychology. So we'll start this conversation just by looking at some fun facts from the scientific method as they pertain to psychology, right? The brain can recover from massive early childhood brain damage, right? We've done studies, we've looked at case studies, we've done research on this topic, and people have come to find that if children undergo severe early childhood brain damage, right, they can in fact recover from that. The brain is very plastic. It has a lot of plasticity, and we'll talk about that the next couple of days, right? We know sleepwalkers are not acting out dreams. How in the world can you actually study that? We can't get in somebody's brain and see what they're seeing, but we can do research to see what our brain does when we're dreaming versus what our brain does when we sleepwalk, and is that the same? That's the question, right? A couple of other fun facts. Our brains do not have accurate memories locked inside like video files. This is not the movie, what's the movie? The cartoon movie, Pixar, with the little happy, sad, angry, Inside Out. This is not Inside Out. There's no hidden and unused 90% of our brain, right? So many people say you only use 10% of your brain, right? Like that's really inaccurate. Maybe only 10% of your brain like at a time, but even that is a very low number. People often change their opinions to fit their actions, right? Why does this happen? These are all things that can be studied from a scientific foundation to come to specific conclusions, to make theories, and to make hypotheses. A theory, then, is a set of principles built on observations and other verifiable facts that explain some phenomenon and predict its future behavior, right? A hypothesis is a testable prediction consistent with our theory. So we have this theory, we have this idea, this set of principles that we kind of believe, and so then we make a hypothesis based on that theory, and that hypothesis needs to be testable, meaning the hypothesis is stated in a way that we could make our observations to find out if it is true or not. So for example, we have this idea, we have this theory that all ADHD symptoms, right, are a reaction to eating sugar, right? Kids demonstrate ADHD or lack of focus or an inability to sit still and stay focused on one task because of their sugar intake. So we have this theory, right? So what's a prediction from this theory that we can make, right? Our hypothesis could be if a kid gets sugar, the kid will act more distracted, impulsive, and hyper, right? Which are all symptoms of ADHD. And in order to test the all part of the theory, right, ADHD symptoms will continue for some kids even after sugar is removed from the diet, right? So the question is are ADHD symptoms solely because of their intake of sugar, or are kids who have ADHD going to show those symptoms with or without sugar, right? That's going to be a way that we can test said hypothesis. But when we make or test these hypotheses, we have to be very, very intentional by recognizing our own biases and by setting up our experiments and our tests in a way that are focused on finding the truth. Again, that humility piece of the scientific attitude, finding the truth, not just to be right. And so we know that people can use data and information in whatever way they want. They can use numbers to prove they're right, to prove others are wrong. But we also know that there are ways to kind of safeguard from that, right? There are ways to create hypotheses that are designed to be disconfirmed, right? Like I believe, I have this hypothesis that sugar leads to ADHD symptoms. Therefore, I'm going to test that sugar doesn't, in fact, create ADHD symptoms or whatever that might be, right? The goal is to disconfirm our hypothesis, and in doing so, if we do everything we can to disconfirm it, but we can't, we can then confirm that that is in fact the case. We also have this term or idea of operational definitions, which is a statement of the procedures or the operations used to define research variables. So the goal with these operational definitions is really put a tangible, measurable definition to some of these ideas, right? In psychology, we're not always working with numbers. We're not working with really straightforward ideas, right? Is sleepwalking dreaming? That's a super abstract thing to study, and so we really need in the field of psychology to put operational definitions to a lot of these terms. So let's go with our ADHD and sugar example again. How are we measuring ADHD symptoms in observable terms? We can't just say like this kid was more hyperactive than this kid. Like, okay, how do you know that? How are you proving that? What numbers are you tying to more hyperactive, quote unquote, right? And so you might say hyperactivity equals the number of times per hour a student is out of their seat, right? Looking at inattention, you might look at the number of minutes a kid can focus on a task before becoming distracted. Because if you're using these tangible, concrete, operational definitions for hyperactivity or inattention, right, you're able to say, right, Johnny got out of his seat 7 times in an hour, whereas Susie got out of her seat 1 time within that hour. Therefore, we know Johnny is more hyperactive than Susie, and we can recognize, are they eating sugar? Are they ADHD? Same thing goes for inattention, right? Lily can focus on a task for 10 minutes, right? Whereas, I'm trying to think of names, Clara can only focus on a task for 5 minutes, right? Lily has better attention than Clara. What is the cause of that? So these operational definitions are extremely important when we're talking about psychology as a science. So we're going to do a little bit of practice here. I want to look at these. Again, feel free to pause this video real quick and work through these 6 examples, but I want you to think about what operational definitions would you use for these situations. So if we're studying these ideas or trying to prove that, say, a psychologist wants to know if a form of psychotherapy will make people less depressed, what does depressed mean, right? How are we going to actually study this, okay? So take a second, pause this, work through these, and then I'll go over just a couple of potential options. There's like no right or wrong, but just some examples or potential answers. So hopefully you guys got a second to work through these, looking at kind of these operational definitions of like, how do you define this abstract idea of depression, right? You might give somebody a questionnaire, say it's like a 50-question questionnaire, and if they answer yes to more than 30 of those questions, right, that would be grounds for saying somebody is depressed, right? And if they take it 3 months later and they get less questions, they say yes to less questions, we know that they're feeling less depressed, right? We're putting a tangible number to kind of an abstract idea. Looking at the next one, the teacher wants to find a way to help make Billy act more friendly towards other children, right? And maybe that means the teacher gives Billy a star every time he shares his toys or his snacks or whatever he's sharing, right? And if 1 week he has 3 stars and the next week he has 5 stars, we know that what we're doing is working. We're helping him be more friendly towards other children, right? Boys show more affection toward their father than toward their mother, right? How many times do they say, I love you? They say, I love you 5 times to dad and 2 times to mom. We are putting an operational definition to affection. Wayzata High School is a better school than Edina High School, right? Maybe we're looking at average GPA, right? Maybe we're looking at average ACT score. Maybe we're looking at percentage of graduating or of seniors who graduate high school, right? Those are tangible numbers to better, right? This term, quote unquote, better. College athletes are not as smart as regular students. Again, you can do GPA, average GPA, you could do average years of graduation, like whatever, to say like, how do you define intelligence, right? You might use an IQ test, right? U2 is the best rock group ever. Maybe you're looking at their overall record sales, right? They have sold more records, therefore they are the best. If I just say they're the best and I have no stats or nothing to back it up, right, that's just my opinion. But if I start pulling numbers and I put an operational definition to that, right, we might be more likely to view this as a scientific truth. The last slide here then, we're looking at just, oh, hey, apparently this guy got covered up by a circle. I wish I could just move that out of the way. Apparently not. But when we're talking about the research process, we can use kind of an example of depression, right? We have theories. Low self-esteem feeds depression, right? That's a theory that somebody might have. And so that leads us to a hypothesis. People with low self-esteem will score higher on a depression scale, right? So we're putting an operational definition to what it means to be depressed, and that's a depression scale. So maybe that's monitored through a questionnaire of sorts. And so then that leads to our research and observations, right? We administer tests of self-esteem and depression. See if a low self-esteem on one predicts a high score on the other, right? And we can take this scientific method and really understand why people behave, feel, think, act the way that they do based on our research and understanding human nature.